Okay, and this is our last section. So looking at a couple of studies here. So first you're looking at the AARP. So AARP stands for American Association of Retired Persons. That would require in the United States that these individuals are older than 65. Okay. So just keep that in mind. Also notice the timestamp, right? 1995 to 2002. Little bit of an older study, but still helpful for some context here. They categorize people as inactive, active but not meeting recommendations, meeting moderate physical activity recommendations, so that's your 150 minutes a week, vigorous physical activity recommendations, which in this study they said was 60 minutes, or meeting both moderate and vigorous physical activity recommendations. Okay. And what we see here is that there's a curvilinear, what we call a curvilinear dose response relationship. So linear would say there is no deviation, so it's a straight line. So right, we see here, looking at all-cause mortality, there's a little bit, it's not quite straight right there. So between the vigorous and the moderate and vigorous, right? Looks like vigorous and moderate, maybe not a big difference, but there is a difference between the moderate and vigorous group and then just the moderate group, okay? So vigorous might come into play somewhere there. So that's why we'd call it a curvilinear dose response. And all a dose response really means is that at each level, we have a decreased mortality risk, right? And we do see that, which is why you could say still this is a dose response. And even here, technically, when we're looking at cardiovascular disease specifically, so cardiovascular mortality risk, yeah, it's not perfect. It goes down here, goes down again, actually see a slight uptick here, and then maybe slightly down here as well. So maybe which recommendation you meet doesn't matter quite as much for mortality, for cardiovascular disease mortality, but just that you are being active, right? But in any case, oftentimes a researcher would say this is still an inverse dose response relationship. And same thing here, it's not quite perfect, right? Because these two are pretty much the same level. So between insufficiently active and meeting moderate guidelines, no real difference. And then even when we get to the vigorous, maybe when we do vigorous and moderate, little bit decreased mortality risk for cancer. But also notice that it's not quite as significant for, also I just realized I didn't have my laser pointer going, not quite as significant for cancer as it is for cardiovascular disease, and definitely not for all-cause mortality. So think about that in relation to where are diseases, right? These are the things killing people. So all-cause mortality could be any of these, which is partly why we would expect to see slightly greater impact in terms of how physical activity impacts all-cause mortality as opposed to just cancer mortality, right? Because cancer is only a part of all-cause. Heart disease is only a part, right? But physical activity might be impacting stroke pretty significantly, maybe chronic lower respiratory diseases, right? Maybe even unintentional injuries through an indirect relationship with sleep, right? So just keep that in mind, and that's why we would expect to see what we do see here in terms of the total effect on all-cause mortality being the greatest. Also notice although they didn't stratify by race, they did control for any effect that race may have here. So like what I was talking about earlier, there's some research that maybe, especially female Hispanic population may not benefit quite as much from physical activity as other portions of the population. This research would not support that claim because, right, it says this is independent of race. It didn't look at each one individually, but it did say, okay, race overall did not have an impact on these results. Okay. All right. Harvard alumni study, right? This comes up pretty often. Here, note absolute intensity levels. These were your cutoffs. Okay, so similar to what I was saying before, only moderate was 4 to 5.9 instead of 3. Okay, so you see that differ a little bit across papers. It's not always the same. And essentially what I wanted to point out here was that energy expenditure seemed to be really important, particularly across moderate and vigorous physical activity, but they did not find that light physical activity was. So calories expended in light physical activity, basically this study is saying those don't seem to decrease risk. Now we have more recent data that does support that light physical activity, in fact, is having an effect, but Harvard alumni study is a very big study, so you could probably argue either side. You could say it's really important, it is important, or it's not important. From a public health perspective, I would absolutely say nope, it is important, if for no other reason than that it can be a gateway to helping people to engage in moderate activity, right? It may be where somebody needs to start. Okay. Um, okay. Oh, it is pretty interesting. The Harvard alumni study looked at weekend warriors, and you'll see this term used in the paper that you read this week as well. Weekend warriors. So that's the idea that I'm hitting recommendations, but I'm hitting them in 1 to 2 days a week instead of across multiple days. And what they saw was that among those with high cardiovascular disease risk, that it was not impactful. So in people who have high risk already, being a weekend warrior is probably not enough. They probably need more frequent physical activity. Whereas if you are a relatively healthy population, a weekend warrior is probably going to get you by, and you'll get right here. It says 59% lower risk of death. And I think for the other group that they were comparing to, I think it was a 60% decrease. So there was no statistically significant difference between the two groups there, if you are healthy. I want you to think about that question for a second. So why would increased frequency be more important for unhealthy individuals? First of all, what's an unhealthy individual? So in this study, I believe unhealthy individual was classified by having been diagnosed with a chronic disease, similar to the article we read last week. Okay. So I think diabetes is the easiest disease to tackle here. For a population experiencing diabetes, why might more frequent physical activity be important? This is a question for you to think about while I have a drink. All right. So I'm hoping if you haven't come to a conclusion yet, pause the video, take some time, really think about this. It's helpful for you to come up with an answer instead of me just giving you the answer. But for a diabetic population, right, what's the issue? What's the health issue? Well, they're not regulating their blood glucose levels very well, partly as a result of insulin resistance. Now, this is specific to a population with type 2 diabetes. Type 1 diabetes is a different sort of animal, and we can tackle that. But in either case, whether you are experiencing type 1 or type 2 diabetes, regular physical activity is one way to help control blood glucose levels. The reason for that is that transport of blood glucose into muscle tissue is insulin independent, meaning I don't need insulin for that process to happen. Whereas for most tissues in the body, I need insulin present in order to move GLUT4 transporters to the edge of a cell membrane to then allow glucose into the cell. Okay. So that's part of why, like, especially if I have high blood sugar, right? Um, doing some exercise can help to reduce that very quickly. Now, you can have hypoglycemia too, right? So then if I decrease that blood sugar really quickly and I haven't resupplied it, I can now be hypoglycemic, and that's an issue too, right? So you often see like some shakiness, or people get really white sometimes. You can see people experience syncope or passing out. I haven't seen it personally, but you know that it's out there. So anyway, that's why frequency may be helpful, right? If I got it all in one session, especially in a population experiencing diabetes, I actually might experience hypoglycemia in that case, and then that's a different issue, right? But if I'm doing it regularly across the week, that actually may help to control my blood glucose levels. So I'm not surprised by seeing that finding. Okay, a couple of article specific things. So an umbrella review, what is it? So an umbrella review is a review of reviews. Okay, so a meta-analysis or a systematic review, let's start there, typically takes a lot of papers and tries to combine the findings somehow. Not often, statistically speaking, do they do this. It's sort of just reviewing what all of the studies have found. A pooled analysis or a meta-analysis both will take the data from lots of different studies and combine them, okay? What an umbrella review does is it takes several different meta-analyses that have already combined lots of studies and takes the data from them and makes an even bigger review. So you can see a lot of data points from these. There is a slight difference between a pooled and a meta-analysis. So pooled analysis doesn't weight the data. So all I mean by that is oftentimes people will weight their data based on some external criteria. So the US Census is a pretty common one. So the US Census is performed every 10 years. And the idea is that it does sort of list everyone living in the United States, not just citizens, but everyone living in the United States. And so then I know how many people in the United States, which percentage of the United States population fits between the ages of 50 and 60. I have that. I know that because of the US Census. Therefore, I may weight my data. Let's say in my data collection, I only had 10 individuals who were between the ages of 50 and 60, but then I had 40 individuals who were between 60 and 70. I might weight my 10 people just a little bit heavier because I know that they represent a significant portion of the population. For whatever reason, in my study, I just wasn't able to get them. So I might say, okay, this group of people's data is important, and so I'm going to give it just a little bit more weight, is what we call that. Okay, so yes, pooled analysis does not weight data. Meta-analyses typically do. And a systematic review is usually less statistics and more sort of summary. And then the umbrella review is taking all three of those and combining them, okay? One thing you often see is a stratified analysis. So I sort of just gave you an example of that. Stratified by age, for example, every 10 years is pretty common stratification method. Race is a common strata. Sex is a common strata. So you'll see that come up in the article. Longitudinal cohort also comes out, so pay attention to that. There's a difference between a cross-sectional cohort. In fact, it wouldn't really be called a cohort if it's cross-sectional, and a longitudinal. Longitudinal means that I've followed people across time, right? I can look at change over time, and I can look at incidence across time. If I'm just looking at cross-sectional data, right, I can't calculate incidence. I can only calculate a prevalence, for example, in that case. Also take note in the article, this is global data, right? So this is not just in the United States. They actually combined at least some studies out of Asia I saw. I think there was maybe a couple studies out of Spain, definitely several out of Europe coming into this. So this is global, not what you're reading this week is global data, not US data. And that's helpful to know. Pay attention to categorical versus continuous. So several of the articles categorize. All that means is, let's take fitness, for example. So VO2 max. A VO2 max is a continuous variable because I could have somebody whose VO2 max is 15 mLs per kg per minute, and I could have somebody who's 65 mLs per kg per minute, or an infinite number in between. So that's what I would call a continuous variable. Sometimes to make data more easy to interpret, we categorize. So I might say people who have a fitness level between 15 and 25. I might say, okay, these are low fit individuals. Okay. Then I might say between 25 and 40, I might say are average fit. And then 40 and above, I might say are high fit individuals. Okay. It's just a way to categorize. So, but I might look at associations with those categories instead of with each individual. Okay. So know that there's a little difference there. Also, pay attention to positive, negative, and curvilinear associations. So what we have here, bottom right, this would be a positive association. So as sleep, here it's sleep quality, as sleep quality improves, my flourishing increases. Okay, so as one variable increases, the other variable increases. That's a positive association. What we have here is a negative association. Okay, so as physical activity volume increases, cardiovascular disease risk decreases. Okay. This is more typical of what I might see in categorical data, right? I have 3 bars here. So these probably represent 3 different sort of individuals. or sorry, 3 different categories. Okay, so this is categorical, and I'm sort of categorically showing an inverse curvilinear dose response, right? Linear would be if I could draw a perfect line through them, which actually here I might be able to. Um, uh, Whereas curvilinear is I can't draw quite a perfect line. I've got more of a curve here. Okay, so inverse, right, is as one variable goes up, the other variable goes down. That's also called a negative correlation. Positive is as one goes up, the other one goes up. Okay, and then curvilinear, curve versus straight. Okay, those will be helpful things to know. Consider interactions as we go. So there may be an interaction between BMI and fitness level, for example. And we can talk about that in class if you have questions. But note what did they control for in the studies and what did they not? In most studies, they controlled for BMI and fitness level, or at least one or the other. Biomechanics can make a difference as well. So again, pay attention to that. So those are interaction variables, meaning they're variables I'm very interested in. I think they have an impact and I want to know what the impact is. Then there are variables that we just adjust for. So in the AARP study, right, I pointed out they adjusted for race. That means, okay, that's a variable that I know may have an impact, but I'm not necessarily super interested in that variable. You'll note that they did not look at socioeconomic status or ethnicity in this study. I would like you to consider if they had, what might you expect to see? Would we expect as socioeconomic status increases, would we expect to see decreases in mortality? So that would be an inverse relationship. Or as socioeconomic status increases, would we expect to see an increase in mortality? So a positive relationship. And why, right? Same thing with ethnicity. Is there a reason why I might suspect that that has an impact? I'd like you to think about that. Some other interpretation considerations that I want you to think about as you read. First, think about the time period. I would be, if we were in class, I would ask, does anybody know when the iPhone came out? The iPhone came out in 2007. Our screen time has increased dramatically over the last 2 decades. So I would expect that to have some impact on the results. This study is predominantly using data from prior to when the iPhone came out. Some of it covers a little bit of that time frame, but I would expect in the next 10 years to see some more data come out that we may see different findings because our environment's changing so rapidly. So think about that. Think about adults versus children. Would we expect to see the same things in children, different things in children? Because this study isolates to adults only. Self-report and subjective experience. Think about the pros and the cons of that. What's a pro of self-report and what's a con? And if your typical go-to con would be, okay, well, people are going to lie. Yes, that's true. But we actually know people are going to lie, so we can also adjust for that. And also, typically, people lie relatively uniformly. They fudge their numbers. They think they're more active than they are. And that's across, even in active populations, we see that. So maybe it's not that big of a deal, right? And that's where we do validation studies, right? And these surveys have been validated. So think about that as well. Is self-report reliable? Is it not? What about subjective experience? So in one of the studies, they talk about how they categorized walking based on brisk walking. Okay, well, what is brisk walking? And is it brisk to you? Is it brisk to me? Do we think of that as the same level, right? Like it's an interesting question to think about. Consider outliers. So one part of the study talks about people who experience really high levels of physical activity. I would like you to consider what percentage of the population is experiencing that. It's something that I get really frustrated with because there's actually quite a bit of research on that now, on individuals who experience really high amounts of physical activity, and does that increase mortality risk? I think maybe we should study a more average population. Let's study where most people fit. The 1% of people who are getting high levels of physical activity are likely not really doing it for their health. They're doing it because they love it. They're doing it because they want to do it. They're doing it because they're maybe addicted to running, right? Like that might be a really different issue in a different population, and maybe it warrants studying, but I really feel that we should, from an epidemiologic standpoint, be more concerned about where most individuals fall. And those people are well outside of 2 standard deviations from the norm in terms of how active they are. Light physical activity, note none of these studies, as far as I remember, address light physical activity. None of them address resistance training. Okay, we'll get to that in the semester, I promise. And also consider the type of heart failure. So in one study, they briefly mentioned this, so I wanted to bring it up. There are two primary types of heart failure. There's systolic failure and diastolic failure. The systolic failure would have a low ejection fraction, and all that means is that my heart's filling up with a lot of blood, and I'm not able to pump very much out of the heart with each pump. Okay, so that would indicate that my heart's not super strong. So that's systolic heart failure. Diastolic, on the other hand, would say that actually I'm not filling that much and I'm not pumping that much, but I might not be pumping that much because I'm not filling that much. So that is an issue with the heart's actually not able to relax completely. Okay, so really different versions of heart failure. And if we parsed out the people experiencing one versus the other, we also may see some differing associations. So just something to think about. Really brief review on stats here. So effect size estimates is a word that they use here. An effect size estimate could be a lot of different things. It could be a hazard ratio, which we talked about last week, could be a risk ratio, could be a coefficient that's represented by beta. Often it's a mean difference, meaning I take one group's average and I subtract the other group's average, and then I usually would divide that by a standard deviation of one of the groups. So just know that that's what that means. There's a lot of ways that we could measure an effect size. In this study, it's mostly hazard ratio, at least for the first 3 figures. Hazard ratio represents a change in the outcome, so a change in mortality with a 1 unit change in the variable. Okay, so this is a really common figure that you'll see in a meta-analysis. So I want to spend just a little time here. This line represents no statistically significant difference between groups. Okay, if my confidence interval, so the confidence interval is represented by this line, the horizontal lines, okay, and then the point estimate, meaning the population average, is represented by the diamonds. Okay, so I have this estimate, this is my confidence interval. If the confidence interval crosses 1, I can say I did not find any statistically significant difference between my control group and my intervention group, or I did not find any difference between the inactive population versus the active population. Okay. Then, so we'll take these studies and then we'll sum up. So we'll combine all the data to get a composite score. So this is my big score down here. And what we see is that in males, so they broke it up by sex. So in males, the average decrease essentially in risk if you are physically active. So these were the different exposures they looked at. If you were physically active, this is walking, if you notice, that you decrease your risk for mortality by 34% there, okay? For females, the composite score, we see that they decreased risk by 28%, so not quite as much, but still significant. It's also really interesting sometimes to just go look at the individual studies where they didn't find a difference and see, okay, why might they not have here as opposed to the other studies, if you can come up with a reason. And sometimes you can't, right? But these are also pretty different. Notice this is 1 hour per day. This is 1 hour per week. This is brisk walking, right? So it's just interesting to look at the different exposures. Okay, and then combined male and female data, right? We did see generally a decrease in risk on average, right in the middle, so 20 something odd percent. Real quick, it is helpful. Oh, sorry, that's 32%. It is helpful to look at heterogeneity. So they found what this p-value means is there was significant heterogeneity, which is actually a good thing in this case. We want the population to be heterogeneous, right? If the population is too similar, then we say, oh, okay, I can only say this population is affected. But if my population is really different and I still find significance, now I'm much more confident in generalizing the results to other populations. Okay. Okay. That was a lot. Good luck with the article this week, and I will see you in class on Thursday.